Okay, sorry about the lecture video from last week. I was fumbling around and then somehow I didn't screen share. So when I came home, I only had like a few seconds screen share when I was swapping computers. So I kept the old videos up, which is very close to what we were talking about. So I gotta make sure that I remember to do that today. One track mind sometimes. Okay, so we are going to touch on wireless technology today. I know that most of the jobs, if you are applying for network technician, will have a requirement for wireless. This is also important in the cybersecurity area, as most of you know that wireless network is the easiest area to really for an attacker to really penetrate. So we want to make sure that we understand wireless technology, talk about encryption, and then different standards that you're working with. And we are going to configure wireless in our Linux systems today. I was trying to, decide on how I want to go with the lab. I wanted to give you a little bit more exposure to Linux command line and also the tools that you can use for administering Linux systems. So we'll come back to appliances and things in the next few weeks. Okay, so at the beginning, it talks about WLAN or your wireless local area network. This consists of your access point or your wireless router and the connecting devices, right? And the notes, it gives you the point in how you want to look at the wireless network from an administrator standpoint, meaning that if you want to have a higher data transfer rate, you need to really think about how you would be able to have signal, right, or frequency that's going to span across your network. And we'll talk about how you need to do site survey and be able to overlap, right, your AP so that way you can have seamless coverage in your wireless network. So in the first few questions, it asks you to, for question number one, it asks you to explain the relationship between frequency and distance in a wireless network. We already know that it is line to site. So for example, at home, you might have a wireless router downstairs, or at a corner in your house. And if you're sitting far away from that particular access point or router, right, you will have lower signal shown on your tablet, smartphone, or smart devices. And the same thing with how we look at frequency. So your wireless signal is sent in waves. And so we know that when you're using higher frequency, your signal is shorter. So when you're using 5G on your AC router or your AC devices, just keep in mind that it is a higher frequency band. That means that it goes shorter distance. Okay. Now, most of your devices will function in 2.4 gigahertz, which is a lower frequency band, which gives us longer distance. This is why you have IoT devices or wireless technology that's really equipped mostly with 2.4 gigahertz. So even if I'm able to do dual band, just keep in mind that if you're using higher frequency, you have to be closer to your access point or your wireless device, your router. So that means that when you're using lower frequency, you're able to go longer or larger distance. And this is why, as I mentioned, that you see a lot of smart type of technology like wearable devices, or even at the hospital to monitor patients' heart, it operates at 2.4 gigahertz instead of 5G. Now, current technology, you do see that they are equipped with dual band. Just keep in mind that when you go with higher frequency, you have shorter distance, right? So that means that I have to implement some kind of repeater to take that signal and resend it across. So when you're using a repeater, that simply takes your same signal and repeats it, right? Hence the name, or retransmit it across to a longer distance. So we can relay the signal further if you are using higher frequency and if you need to go longer distance. So that means that we have an indirect relationship between distance and frequency, right? So when your frequency is high, your distance is low. When your frequency is low, your distance spans longer. So in a lot of the current network, when you see an access point, you tend to see that they only operate at 2.4 gigahertz. Also, you have to consider power consumption, right? In if you have a complete wireless network for your enterprise, that means that you have many access points, right, connected to your switch. They either powered by something, and if you have something like industrial access point, like if you're driving around downtown in the city, and if you have public Wi-Fi for the city, right, normally you would see that they would have solar panel or something that will be self-powering this particular system. And then we also learned that you can also adapt that with Ethernet connection for your AP. So let's take a look. So before we get into some of this, I want to introduce you to some standards, right? You probably heard of them in other classes, but for this particular class, it focused on networks itself. So you have IEEE, and some of the students ask me, what are they really doing, right? So they really maintain the standard. So if we have, for example, a new Bluetooth standard, right, or a new technology standard, a new type of communication standard, it has to be standardized and controlled or managed by IEEE. They have researchers, they have people that focus on specific area to be able to flourish specific standards. So you have standards that are being released, right? And they are currently working on it for multiple years. And then you've got FCC. FCC regulates a lot of the things for United States. So, for example, that really control how and what technology that we can use. Some of it has to do with maybe possible impact to your health and also communication in other technology. So for example, you can't use a certain type of technology for drones near the airport, right? And drones sometimes use wireless technology. Some other times you might use other forms of communication. So what you see is there's regulation with the FCC and other organization with that. And then in Europe, it's chartered and produced by European Telecommunication Standards Institute. So if your company is in the European area, right, they will be regulated. And also in Asia is a little different. So you do see some flexibility in different standards and technology being used in other part of the world because they have less regulation and in how the technology is implemented. And then your Wi-Fi appliance, Wi-Fi Alliance promotes how your technology in wireless, like Bluetooth and your regular 802.11 standards is tested. Now, can you buy a system that's not tested? You can't, right? Tested, it's just giving you a little bit more assurance in how it can interoperate. That means that I can use it across multiple brands. I can use it with my current network that might not be the same brand. So if it's tested, they will have the label on the box showing that it is tested. And then your WLAN ANA, so your association, these people are in charge of, bringing the attention to the consumer and education. Okay, so there are 3 license bands for United States. Okay, as you can see on the bottom of the page 1, I talk about 2.4 gigahertz. That's one of the band. 5G, you hear that all the time, right? 5G internet, 5G for us in wireless, that just means that the frequency is at 5 gigahertz. So when you hear frequency, automatically it's going to be hertz. right? And that really means the rate for us for the transfer of wireless data. And then on the lower band, long ago, right, you would see that it's at 900 megahertz. So we mostly use in the higher two bands here, right, 2.4 and 5 gigahertz. And so when you look at that, how does this really break down to other frequency, right? You know that all signal across airwaves is transmitted in frequency. So if you're using sonar, right, like for ships or different type of technology there, you would see that it is extremely low compared to your radio signal, AM, FM broadcast. And then when you move into the cellular, that's about 800, 840 to close to 900 megahertz. And then when we get into the wireless side, that's going to be 900 to 5 gigahertz. And if you're dealing with X-ray or other type of machines, for example, like infrared machines, scanners, you know, when you go to the airport and they do the security scan, those systems, the signal is transmitted at the higher range, the higher band. Now, keep that in mind because when you implemented wireless technology with other type of systems that have bands that might be crossing, you have to remember that, you know, just like all communication system, signal leaks and it deteriorates. Also, it can impede signal. When you're using wireless, with like in an old historical building, you would know that sometimes steel plate wall will prevent your signal. Water fountain prevents your signal, so that there's a way that we can stop signal from crossing, or it also we have to work with the challenges of the things that can stop our signal. So just keep in mind of the bands and making sure that you understand that. Because implementation in hospital, for example, you might have X-ray machine, but you have to implement wireless for the nurse stations and the doctor systems. So you got to make sure that, you know, it meets the requirement there. Okay, so I gave you a little bit of history image here. So 802.11 been around for a long time, right? In 1990s to toward early 2000, it became really fully implemented. So for number two, actually, what type of facility is ISM band use, right? So you would see that's used in regular office building, tall rise, or, you know, not necessarily tall rise, but just for office use. You would see that in medical facility or healthcare facility like hospital or urgent care type of environment. You also see this in warehouses. That's what we're surrounded with around here. And then also homes. So if you're looking at the application for wireless with ISM, it's really geared for business and your regular consumer, right? More frequent in the early 2000 up until in the last in the current year compared to what you see before prior to 1990s, right? So historically, in my experience, even when I was teaching, wireless networks became more abundant more in the 2000 because of the availability in the technology, like your wireless router, right? The antenna that come equipped with the wireless router became better. The standards became better. Encryption for those standards became better. So all around, we have improved wireless technology in a tremendous way. Okay, so here in cellular, it talks about GSM and FDMA. So if you have used like AT&T or T-Mobile back in the day, they had used GSM, and also for Verizon Wireless in this area, you see that it uses frequency division multiple access, your FDMA. They have upgraded this to a different type of cellular network now, right? So for code division multiple access, it usually just use a code for each call transmission. And it's a way to spread the data across the spectrum. So each unique code is created for each of the call. across the cellular network, allowing the call to use a broad amount of spectrum in the frequency. So what you see is that we're able to capitalize on it way better than if we were using time division multiple access or the frequency division multiple access, because historically, if you're looking at the 90s up until the early 2000s, you have to use a certain frequency range, which limits you to only 1G and 2G, slower speed, right? Now everybody wants to be on 5G. So in that sense, we have to be able to spread across the frequency so that way the data can get there quicker. And then if you're using, bless you, if you're using LTE, right? And if you're signing on your network, you would see either GSM Edge, right, or UMTS. These technology uses long-term evolution, and that uses a broadband in mobile devices using as a terminals. So we have improved quite a bit because of the demand on how we want the data to arrive quicker and more data. That's, if you can now stream quickly. Imagine in the early 90s or 2000 when you're streaming a video, that takes a long time, right? And it's choppy. So because of the demand, so for example, frequency is in waves. Instead of using one specific format in the wave, they're able to capitalize in the signal in multiple range in different ways. So that means that I can be at 1.900 megahertz or at the higher end at 5G. So it's able to go low to high across, and it's also able to use specific channel for that. So let's say the 1995, you're only gonna be very limited to the lower frequency. So if you're using like the earlier technology, for example, if you're using like the frequency division multiple access, which is what Verizon had used in the past for your FDMA, it's only gonna modulate in 1G. That means that the highest frequency that you can reach for that is 1 gigahertz. 5 gigahertz, 5 times. Okay, and it's able to modulate that across and using multiple spectrum, not just in one area, using different channels.
How did they like come up with, I guess, in that kind of short time?
It's over. Actually, if you look at it, we have spent close to almost 20 years in the improvement of your cellular network. Rolling, landline has to be accommodated, big palm tree, cell tower has to be accommodated. So your reader is able to receive, right, higher spectrum signal along with your smart devices. It's able, so you have to have the consumer devices and the business to be on the same range in order for it to have higher range. So because of your smartphone now, it's able to have the chip that's able to process higher frequency. Then you also have cell tower and also landline that's able to accommodate higher data rate. All the cell tower is connected to a landline, a fiber optic line that runs across the country for T-Mobile, AT&T, Verizon, etc. Right? And they tap into the larger network. So ultimately, everybody's on an TCP/IP network, but it's still having to transmit through airwave. And so until you have reader and receiver on the same frequency, then you're able to have this technology.
So everyone's kind of controlled by an IEEE.
Yes, 100%. That is true in every sense. Okay, in your regular network and in your mobile network, 100%. They can regulate how you send data because ultimately when it leaves your home, which is your small network, from your business network, they can control how your data can go. 100%. So you pay for what you get, right? Back in the day, you guys know, you pay for your data rate. You want more data, you pay more, right? This is how they can control it. And they throttle your data when you reach that cap because that way they can accommodate more, right? Ultimately also profit more because it's still a commercialized environment. Okay. All right, good question though. And I can go down that rabbit hole. Okay, so for number 3, we know that your code division multiple access, your CDMA, it uses a unique code for each transmission of the call. It's able to spread the data across the spectrum. So your payload, right? Like even if you are streaming, even if you are using large amount of data, it's able to expand that so that way you're able to get your data sooner or as quick as possible, not sooner, for the speed, and you're able to, so we can FaceTime and it's close to real time. I don't believe in anything 100% real time in your consumer system, right? You can be close to real time, but there's no actuality that you can be real time. A lot of the software and technology, they claim that they have real time. You will be about maybe off in nanoseconds or microseconds, but you cannot be 100% real time. So we will be close to real time in how we communicate with our family members if you are doing, video conferencing or other things on the internet, like playing games. And then your long-term evolution, your LTE. This is the standardized broadband communication for mobile networks. And originally you see this with GSM, Edge, and UMTS. So the majority of your mobile devices fall into this category, your LTE. You hear the commercial all the time or see it, right?
Yes.
Yeah, so now you know that that is a specific type or standard for your cellular network and how it's implemented. And so it uses the data terminals to be able to communicate and submit your, so everything, even your voice, right? I talk about encapsulating, so it changes your analog signal into digital signal, right? And it treats it as a data. So when you're making a call, it's transmitted across the network as 011s automatically, right? Because we're on 100% digital network compared to 1990s, we were on analog network. So if you're using, the landline dial phone, those are still analog. But it's still now, if you're using voice over IP networks for your landline, then it becomes a digital environment. Okay, so why are we learning all the old standards? Because of compatibility issues. You might not see some of the old standards now in the current network, but you might come across technology that is legacy, that's older, and you've got to know that some standards are not compatible with others. So I give you a table. You can see 802.11 standards. So your AC is here, right? And you're able to transmit up to 1 gigabit per second, and that's for 5 gigahertz band. Okay. And then if you look at other, like the older 802.11b, this was an improvement from the A, and it supports 5.5 megabit per second or 11 megabit per second. And so for its time, I want to say late 1990s, early 2000, it was fairly fast, because people were still on dial-up at some point in 1990s. And that's a fraction of that speed. So if you have a wireless network and you're using 802.11b, you're pretty modernized, right? But later on, G came out. So you don't see some of the standards making the consumer market because it's basically like, for example, these were used for like business purposes. And then G came out and wow, it went 5 times, right? So if you look at from B to G, maximum for B was 11 megabit per second. And then for G, we can operate that at 2.4 gigahertz and you can transmit at 54 megabit per second. Humongous improvement. Okay. And it's compatible, it's backward compatible. That means that if I have an old laptop that is 802.11b and I bought a new router that's 802.11g, my laptop can connect to the router, right? The router will be able to see the laptop. Ideally, you should use the same standard across, but when you upgrade, you have to gradually do that in the network environment. Bless you. And then later on, after G, 802.11n came about. And also you see that encryption for wireless access also improved, right? People also claim that, no matter whether you're using WPA2 or 3 or WPA back then, everything is crackable. Well, everything is breakable if you have the resources and the time, right? You have the system and the time to put into it. Eventually you'll be able to crack the actual passphrase or key to the network. But they improved that, and as you can see, there are a lot of other standards in between, right? Yes. Yeah, like A has no security at all, right? WPS, and then you have WPA2 for 802.11b, and that was definitely breakable for sure. If you use tool that you see today, you can quickly break WPA2, right? If you have the system and the time to put in to crack that particular passphrase, or key to the network. Now, AC allows you to implement the enterprise for AES, so it takes a little bit more effort and requirement for the encryption, which is WPA2 at the least for AC. But people, you probably seen YouTube video that people are able to breach it, so it's definitely doable. Okay, let's talk about the next field. For number 4, it asks you which wireless IEEE 802.11 standards has transfer rate of 11 megabit per second and has and it is widely adopted, and that was 802.11b. So you can refer to the table on the notes. Which wireless 802 or 802.11 standards that has transfer rate up to 54 megabit per second and has backward compatibility with 802.11b, and that is 802.11g. So make sure we know specific one. So when you're studying for certification or for exam and quiz for this class, just focus on some of the main ones. A, B, G, N, and AC. Those are the main consumer one that you see in the standards that you see in the market. Know the speed. What is the transfer rate? It will say 54 megabit per second for the G, so you can look at the table, right? And then how fast is the AG? 1 gigabit per second at 5G. So certification will ask you those type of questions. Which one has backward compatibility, right? Because in IT, we care about that. We care about when we're upgrading our router, will our device connect to the router, right? Because does it have backward compatibility? Okay. So look at, and there's a breakdown for that, right? So a little bit on you've seen CSMA-CA before, right? This technology was implemented in things like we talked about at the beginning on like different tier in communication. So this is a way, the representation for it is that it sends a request for send and clear for send, so that way it makes sure that everything is clear before the data can be transmitted. So it's kind of like, I'm ready to give you a message, but I want to make sure that you're listening to me. So I first request your attention. I said, hey, Dima, are you listening to me? And Dima would respond and she would say, I am listening to you, clear to send. And I would tell her the message, the data that I want, right? So you see that right here. And then Dima said, I heard your message. That's the acknowledgement, right? So that's how the system communicates. So that way there's no collision, because when you have collision, you're gonna have data loss right here. So that means that, like, if Dima is listening to two people, right, giving her the same message at the same time, right, she will be confused which message is which person is telling me. So what happens is you got to make sure, right? So the systems, they implemented this technology to make sure that the data for each packet is going to be intact, right? It's accurate. Okay. Any question? Next, we're going to talk about channel. Okay. So for 6, it asks you how many channels are configurable in the United States and what are they? And you know that North America is different than Asia or Europe, right? So channel and bands are used differently because of the standards that is regulated for a certain region. So in the United States, you have 11 channels that are configurable for wireless, because they are overlapping 2.4 gigahertz frequency. These are channel 1, 6, 1, 6, and 11 are not overlapping. And then you have channel 2 through 5, 7 through 10, 12 to 16 are overlapping. Now, I know some of you configure your AC router very well. If you look at your channel on the AC router at the 5G, it uses a higher range channel band, right? So it's able to capitalize on that. But for remember that this is for the 2.4 gigahertz band, okay? 2.4 is limited to 11 channels that are configurable, and these are them. Okay. 5G is different. 5G has a wide range of channels that you can use. And so most of the time when I open my box, brand new router, I take it out, I plug it in, it's going to default to auto configurable channel. That means that it's going to go to the channel that is the most available in that range. And like I said, 5G has higher channel groups. Okay. So 1, 6, and 11 are not configurable. They stay static, where these are configurable. Okay. Okay. So that brings you to the next question. Teresa configures an access point to use channel 1 in the building. If she needs to add another access point in the same building, cannot use the same channel. Okay. What channel should she use for 802.11g standard? Because this is a 2.4 gigahertz. That's why I put it in the question. So you want it to be the farthest from the first channel, which is, remember that these are the non-configurable, right? The first one is already here. You cannot use 6 because it's so close to 1. So Teresa has to configure the second access point with channel 11. So that way it's not overlapping. Remember that these are overlapping, so none of these are going to be put in. So if the first one is 1, usually that's default with 802.11g. Then you can go into the actual router interface, right? Like by typing in the IP address or using the app. And then you would modify the channel for that band, 2.4 gigahertz, and you would change that to 11. Just keep in mind that it needs to be the farthest, because it's in the same building. So what happens if I put channel 1 and another channel 1? You're gonna have a conflict, right? Not a good practice. So we want to make sure that each access point has its own channel, especially for 2.4 gigahertz. When you come to the field, you work in the field right now, right? The majority of the time, the things that you set up will likely be like if you go downtown Riverside or any city, Moreno Valley, you see if you look at the light pole, you see sometimes you see access point, right? So that way the bus and the courtroom can use those wireless networks. Sorry. What you see is they are all at 2.4 gigahertz. Why? Because it needs to span the distance, the miles. Okay. Those AP are industrial AP, they are weatherproof, and you also see like solar panel attached to them, so they're self-powered through the solar panel, right? And you see that in a lot of cities. Or farm has some of that too, because they have acres of land, miles and miles of, you know, farm technology has improved quite a bit. You have automation in like watering system, heat sensing, a lot of different things. So the ranches, they have wireless networks also adapted. Question? Also warehouses, you see that too. So where can I find the channel information? You can find that on the bottom of page 4. And then here it talks about the channel and band for 5G. So keep in mind that how you use 5G is important in the band. If you use it indoor, this is what most of us use, right? I have 5G, I have AC, and so do you, probably at home. And then if you use both indoor and outdoor, like maybe at the patio, if you have very large property, some people have like guest houses and, pool and things like that where it's span out, right? They might have access point or router to control their gates and other things. So you would be in the middle range right here. And then complete outdoor for 5G. This is your upper band. Okay. And so it gives you the breakdown on how the frequency and the channel. So the radio band, you want to make sure that there's the least interference. I don't want to say no interference because there's no such thing, right? You know that there's interference in the signal, in how, right, system would send across. So sometimes you might have microwaves that has also high signal, and that can also deteriorate your wireless signal, along with other things like cordless phone operates at about 900 megahertz. So if you have the lower band type system, and then Bluetooth devices too. Okay. So for question A, we want to say that it asks you, what is the benefit of dynamic frequency selection, DFS? This was implemented for the later technology, and this is what we see currently. This prevent interference from occurring in your wireless network. Okay. So that way it's able to modify, right, the frequency in that range, so that way you don't have interference. So when you have interference, sometimes that could be like your EMS. You guys ever walk up to a microphone or a speaker and you have your smartphone in your pocket and you hear that pitchy noise, right? So that's a form of interference, but it's because of how the electrostatic is conflicting, or it bounces back. So that's what you hear is a pitchy noise. Now, in the later technology, what you see is if you have interference, you're gonna have interruption in signal. So they implemented DFS specifically for that. Okay, so dynamic frequency selection, that's a way that we can operate in range. So for your 5G, for 802.11 AC currently, right, it would be that it's able to abandon a certain channel and be able to mark it unavailable and use the next channel in that particular range. Okay. And then it talks about TPC. This is for the phone industry. It's transmit about 5 milliwatts, might not be a lot in the cell range. And so it allows you to connect to the access point and be able to transmit a small amount of power for it. Okay. So that will lead us to number 9. What is the benefit of TPC? I have it backwards. TPC in the wireless network. So TPC enables the client and access point to communicate with reduced amount of power. The client machine will use enough energy, and so that way it will preserve it for the connection in the access point. This will conserve battery and also reduce interference with other neighbor cells in the wireless network. So this is a way that we can reduce some power usage through the reservation with this particular technology. So my new smartphone does that. They have it where it would turn on a certain globe. And you ever notice that when you're in an area when it keeps seeking wireless network, it just absorbs all your battery power, right? Because it keeps having to send out that signal, and every time that it does that, it consumes a lot of power. In the newer smartphone, it does less of it. Okay. And then it also regulates it. So on my smartphone, anything below 80% of my battery, it's going to go into reservation mode, and you can control that with the new Android UI to be able to preserve some of that. So it automatically kicks into the airplane mode so that way I don't consume a lot of my battery, especially, and then it also stores specific configuration for the network in a certain way. So just think of it like a way that two systems can reduce power consumption in industrial area where you don't have a lot of, power sources directly to it. That can be of importance. Okay, so where can I find this information? At the bottom of page 5, going to the top of page 6. And then in the later technology with the standard 802.11n and also AC, you see that they added MIMO, need to know MIMO for the exam, maybe certification also. It means multiple input and multiple output. So you're able to receive multiple frames through the antenna using multiple paths. Okay. This is a way that you can have spatial multiplexing, and it also do channel bonding for both bands. So when I say channel bonding, meaning what? Combining the frequency from multiple channel, right? So that's different than what you see in the only 2.4. We talked about like there's some that's not overlapping, and those are the channel we're going to use. But in the 5G range, you see that there's a group of channel that you can use. So typically when you turn on your systems, you would see that your router might operate at a certain channel at a certain speed, right? It would say this channel at maybe 60 megahertz. And so if you select channel bonding, it's able to combine two channel and give you higher speed through the combination or the bonding of the channel. I saw Dima's question coming, so I wanted to address that right away. Any question? Yeah. I'm sorry, say it again. The spatial multiplexing Yeah, the definition for spatial multiplexing is just it's able to send multiple frames down multiple paths. So think of it this way. Before, we're only able to send one frame down one path, one way. Okay, one channel. Now, because you're able to have multiple channels combined, just think of it like I can send one person down the road and I need to send 100 people down to the destination. That's going to take me a long time. Okay. Now I'm able to send 2 people down 2 roads, right? So I'm doubling the speed. I'm able to address that at 50% in the speed, right? So does that make sense in how it's able to multiplex in pathways that able to send waves across the channels and able to bond the channels. So you're able to have more frames and each frame will contain some data. Okay, some additional benefits are also being discussed here, right? I recommend that you go through and read it, try to familiarize with the terminology. Not all the topics makes the assignments questions because it will be very, very long, but I would encourage you to read through the notes. Okay, 11. Oh, sorry, I forgot to answer 10. What is the purpose of MIMO, multiple input and multiple output? So that way we can have multiple transmitter and receiver antennas to increase data throughput. Hence, this is what you see, right? If you look at the old router, there's only one antenna, okay? On the newer system, some of them, you pay $100 and something for top of the line wireless router. What you're gonna get? 5 antennas sometimes, right? So if you're able to have more transmitters, those are just chips that's being built in to send. And the antennas, we might have 3 or more antennas, and they are omnidirectional, so 360 to be able to receive more. Okay, you go to your grandparents' house back in the day, you have one antenna for the TV. If that antenna goes down, no TV, right? But now you have 3 antennas for the router. So if one antenna goes down, to the other 2 can still work. You're still able to receive. So you have more information assurance in that sense. Okay, 11. Carlos bought a new wireless router and found a Wi-Fi sticker on the box. What does the sticker imply? The sticker usually have a check pass certification. So the router has passed certification testing for that standard. That means that it's able to interoperate with other brands, like what I said, right? So Wi-Fi Alliance is a nonprofit group. They're formed to be able to test these devices. So some brand, they don't submit it for testing and they can drive the cost down. You see that when you go on Amazon or one of the websites like Best Buy to go find a wireless device, not all of them are fully tested. But it's okay to use. It's just being tested, just assure you that it's able to interoperate for that standard. Okay, we already know from the table earlier that the transfer rate for your 802.11ac is max 1 gigabit per second. And that is tremendously faster than what we've seen in the past. When A first came out, you saw 54 megabits per second for that standard originally. So we were, not too bad, not too shabby at the beginning. Any question? Okay, so certifications, if you go for CompTIA certification, likely that you're gonna have those practice lab questions, one like find an IP address or set static IP, something like that. Then you're gonna have scenario questions and similar to this, right? So they want to make sure that you know how to troubleshoot and how you would look at wireless technology standards and how to overcome some of the challenges, etc. 13, Paula wants to upgrade her wireless network, right? And mostly for speed. So she purchased a new router, that's 802.11ac. Her home network, she's using 2 laptops that are older that uses 802.11n wireless adapter that's built onto the laptop. So what is the maximum transfer rate for Paula's system? How can she improve the transfer speed for wireless network? Remember what I said earlier, right? Technology to full speed needs to be in the same standard. If it is not, when we're upgrading it, you are going to be limited to the transfer rate of the older standard. So the maximum transfer rate for the laptop, because it's the older standard, it's going to be up to 450 megabits per second with antenna. Without an antenna, most laptop comes with a built-in antenna inside, you just don't see it, right? The older laptop, you might have to add an adapter with antenna, like what you see with your adapter with USB that you may be using today. So the laptop transfer rate is about 300 megabits per second. So to upgrade for overall, both laptop and router, just make sure that the standard is exactly the same. So we want to get a USB adapter that is compatible with her laptop system, and it is AC standardized. That will allow her to transfer at up to 1 gigabit per second at AC, 802.11ac. Understand? So this is an actually cheap upgrade. Now you can probably get, one of those adapter that you have for your lab today, less than $20. Okay. I would recommend buying one with good antenna. Yeah.
I know the older pubs didn't have it, but now we do, so you're saying.
So the wireless adapter, let's say you bought an old laptop 10 years ago, right? Some of them had a built-in antenna on the adapter itself. So they come on the motherboard, okay? And when you open it up, it would not look any different than a chip, right? But the chip actually has antenna equipped. In the current laptop, that's what you see, right? Sometimes there's an indication that is a separate chip for that, or but it is equipped with an antenna inside. Don't necessarily is not your typical antenna. So if you want, so for the people who attack wireless network, right? For those of you who aspire to be ethical hacker, the antenna is going to be your best friend. Okay, it's going to overcome distance and signal challenges. Okay. So that means that you need to get adapters, things that have antennas, so that way you can receive signal quicker. Okay. So built-in antenna is just as good as it's supposed to be, right? But if you have additional powerful antennas, so why do people get the what is it, the Yagi antenna, the one that goes on the roof? Why? Because it is better than the regular typical antenna that's like a coat hanger inside your home, right? You've seen those coat hanger antennas? I'm too old now. I just date myself with that. All right. 14. So we know that she needs to buy adapters, maybe USB adapter. That's probably the easiest, right? $20 each. That's a $40 upgrade, and your transfer rate is tremendously improved. 14. Mac's office is 200 feet from the company's access point. Why is Mac's laptop transfer rate at 15 megabit per second much lower than the actual standard speed? Why? Because line of sight, right? Because there's degrading in signal due to distance. So how do you solve this problem? If you are the engineer, right? You walk into the network environment, you're new at this job. they have access point for the employee. They complain that when I go to my desk, my computer, my laptop is really slow in getting internet. You already know why. That's line to site. So do a site survey. You can use your smartphone, walk the distance to their desk. So how do I solve this? Get a what? What do I get? Two things that you can get. One is an amplifier, right? So what's an amplifier? It takes that same signal and increases, right? So that amplifier needs to be installed where? It needs to be connected to the access point so that way, or receive the signal from the access point so that way it receives that, take the same signal, right, and increase it closer to max desk, right? That's the dead area, okay? You can also get a repeater. The repeater, its job is to take that same signal and duplicate it down the line, also install it near max desk. So you can do one or the other. Sometimes you would see amplifier that are also repeater. Or what can I do? I can put another access point, can I? Right? For the need. So if they're like 15 people like max there, you need to probably put another access point to scale out. And some access point also have amplifier. So typically it's just a chip inside that system that takes that signal and increases it. Okay. So it's because of degrading in signal due to distance. So the waves get less as it travels through the air. Why? Because you have objects that probably impede the signal, like microwave oven, other wireless devices, walls, water, glass, especially office building. There's a lot of glass, right? Signal bounce and signal gets lost or degrade. Okay, 15. In wireless network, what type of devices connect all components together? That will be your access point or your wireless access point. So my question for you is the access point considered the router? Is the router considered the access point? Because I see some students use this interchangeably. At home, that's correct. Your access point is your wireless router inside your home. But in most business, your access point is not a router, okay? A router is a router. So when you're here, RCCD, your access point is your access point. You see, when you look at the wireless network, you have many access points here in this institution, right? But they might have a few routers, could be also only one sometimes, to be able to route traffic, and that those access points are connected back into the switch, and the switch send that to the router. It's routed out. Okay, so they cannot be used interchangeably in a business environment. If you have a small business that use one for both, yes. Okay. So how can I find this information? So after all the standards, I give you some pictures so you can see the frequency and the band. And it talks about devices. So we know a wireless. So if you install an adapter, it would look like this to your PC, right? This goes into a bus. It's a slot on your motherboard. Now, if you get one for your laptop, right, usually you should just get a USB one. That's the easiest one. But if you need to get an actual adapter, just make sure it fits, and you should look for one for that laptop model. Usually most laptops now are very slim. You cannot add more devices to it. So get a USB one. Omnidirection antenna just means that it's able to go 360, or you can also see point to multiple points, so all direction. Okay. And then you have a Yagi antenna that's going to be point to point, and it provides a greater range, right? And it also, their power is a single direction. It's a good choice if, for example, I need a Yagi antenna if I need to connect one access point to another access point. Okay, it will be direct sending and receiving signal from one device to another device. Okay, but if I need an omnidirection antenna if I'm connecting many wireless devices to one, like your access point or your router at home. You have like 15 devices that are connecting to it, right? So you have point to multiple point, okay? So you have all the endpoint system connecting to it. So you need an omnidirection antenna. So for 16, what type of antenna is used for access point? We want omnidirection antenna because we have many wireless devices connecting to it. And Yagi antenna would then be used to connect two access points together. They are just one direction, right? Provide an example of an ad hoc network and how do you install this kind of network? So ad hoc network is, it could be a wireless network. Sometimes it can be a wired network, but in a wireless sense, you might have two computers, two laptops connecting using their own wireless adapter. You simply just install and configure the wireless adapter. So today, like when you plug in the USB and configure it, install the driver for it, you are going through this part. Now, ad hoc can be that like they can see each other, but they are, they can drop off at one point or another. You really don't you don't have a lot of administration with the ad hoc network. So, so here in the next part for page 8 and 9, it talks about that. So you need to allow the ad hoc for the service set. And so it walks you through some of the highlights here. So it uses IBSS. Make sure you know this term for our quiz or exam. Independent Basic Service Set, which is where one device can see another device this way. So we would rely on hardware and software in order for the system to communicate. So if you have something like a peer-to-peer based type of network that is wireless, you are also having an ad hoc network. You can have it range up to 100 meters, right? Typically, but the farther you are, the less signal you get. So the transfer rate becomes less. So if you're right next to it, you are likely going to have a faster transfer rate. And if you're using infrastructure mode, you're using basic service set, your BSS, right? And this is typically with your access point. This is incorporated. So when you look through the configuration for your access point, you typically see your option for the basic service set. So 19, it says Mark is installing a wireless network for a small business, which consists of access point, small business server, laptops, wireless printers, right? What type of wireless network is Mark installing? And this is called an infrastructure mode, which provides the BSS, your basic service set. For 20, to ensure that the user is able to access wireless signal, what is the recommendation when installing multiple access point inside the network? Usually, if you have a large wireless network, you will have multiple access points. In addition, for security purpose, you should have multiple access points. For example, if I run a hotel, right, I would have one access point for the guests who are staying at my hotel. and one access point for my employees that are working at the hotel, right? So if you're installing multiple access point inside the network, they should be overlapping in signal at least 10% or higher. So that means that your signals span the range, the circle that you see in the image on the notes. They need to overlap by 10 or higher percent. So how can I tell? You're going to do a site survey, right? What is the radius of your access point? And at the edge of that radius of that circumference of your wireless signal, right? You have to move inner about 10% so that way that signal can reach, so you don't have dead spot. Okay. If you ever drive through Ritchie Canyon, right? I don't know if they resolved the problem now, but I haven't been recently. But if you ever go through Ritchie Canyon, you often see that one dead spot, right? Where all the hills end before you reach Colton, right? Or when you're coming through from San Bernardino past Colton, where, before you see all the donkeys, right? When you reach the top of the hill and when that hill dips, you're gonna see, the challenge is that there's no cellular signal there because there's no overlapping in the mobile networks across. People tell me that Verizon you still get a little bit of signal, but I know I use T-Mobile, so my calls usually get dropped right there, right? So to fix that problem, how do you do that? They just need to put another cell tower there for AT&T and T-Mobile. And who owns like all the little prepaid sub networks. So we need to overlap 10% or higher in design, okay? Okay, almost there. I know this one is kind of long. So the main difference between the wireless standalone and the control-based wireless network, how are they configured? The standalone controller do not have the full OS, okay? They are managed independently or individually. So that means that if you have 10 access points, you're gonna have one controller for those 10. Understand? Because you cannot have them 10 individually. That's too much to manage. So you're gonna have a control system that control the other access point. Okay? And that streamline everything. Now, from an attacker standpoint, well, if I disable the control system, then I can, maybe modify some configuration for the access point. So you got to make sure that's protected, right? And that control system is connected to your network through the switch as well. Okay. Now, if you have a standalone controller that is independent, let's say that you only have one access point that you need, right, for your property, there's no controller. Itself is a controller, right? So if you have a lot of access point, ideally you should have a control-based system, and that would run a full OS. And sometimes the system itself would have the interface where you can go and configure, right? But the standalone one, you just have to modify the access point within. So you would go to its configuration, so it doesn't run a full OS. Any question? Okay, see how this one overlaps 20%? So that's ideal, right? So we have channel 1 and channel 6. This is still kind of close. I would not use channel 6, but in the same building, it would be okay to do this on a 2.4 gigahertz if you have two separate buildings that's kind of close by, and you're not losing signal in between. But if you're looking at if let's say it's a large warehouse, you got one access point at one end and one access point at the other end. You just gotta make sure that if it's 2.4 gigahertz, right, use channel 11. Okay, so for the controller, you can see some information there on your page 11. Okay, and they talk about thick access point and thin access point. So You can have a standalone system where you can configure each one, or you can have one system that administer. This is a controller for the other access point. Okay, so I believe in using the controller if you have many access point. It's just making your life a lot easier down, if you scale out also, if you increase in wireless usage. Some information about using a hotspot. Okay, so I mentioned some of this already. The farther you are from the access point, you are gonna lose signal. Distance plays a big key in your signal transmission. If you have walls, right? If you also, so don't think like if I have a 5-story building, put one access point is not adequate, right? Also, you gotta look at the floor for each building. If there are walls in between, like sometimes they have dividers for offices and walls. So looking at like how wide is your building, so you can have the range in 25 feet, okay? But don't go crazy and install 100 access point in one tall rise, right? We just want to make sure that it's efficient and adequate. And then if you would have interference if you have other systems that operate in the same frequency, just keep in mind, right? So that brings us to also a lot of things like when I go to the stadium, why cannot I cannot stream from, watching a live game, like a basketball game or a baseball game. Why? Right? Because they have shield for signal to, mobile signal to be leaving because they are streaming and they're charging for the stream. Right? There's also technology that you can buy for that. You know that it's illegal to create signal reader and scanner in a specific range, like because drones and wireless kind of operate in close range, right? I know that they sell equipment, and I was probably interested in making one. But so if you use it illegally, right, you can land yourself in prison for life, right? So there are specific companies that they charge a lot of money to do these things, like to create, and they do like signal jammers really well. So they put up a shield so you can't stream from inside until you leave the facility. Then you can post whatever you want on social media. They can do it that. But in businesses, to prevent signal from leaving, they can use decoration like fountains and glass and walls and different things to really represent, right, like objects that will be able to back signal. So it talks about that there. Okay, so what are the factors in signal degradation, losing or lessening your signal? Distance walls, protocol limitations, interference from other devices or objects, right? Water is actually one, water fountain plays a big key. You see that a lot in a lot of the larger building like hotels, right? Sometimes they use it for decoration, but a lot of the times they use it for physical security reasons, and other things too. So if we're looking at that way, you can also have glass, to bounce off signal. Any question? So I haven't really dive too deep into the encryption technology because I believe that there's CIS 2741A and the other classes that really address that. But you should always use WPA2 or higher. I think there's 3, right? That comes equipped with your new technology. And AES is probably one of the common one that you see that's implemented in a lot of the wireless technology. It comes with all your smartphones, all your devices. So use encryption is gonna buy you time, right? It doesn't mean that you have full protection, just like everything in security. That's why the industry always demand people, is because we don't have 100% solution for anything. And so how you configure it and how you use it is of importance, right? Okay, so before we answer the last question, I want to touch on these because some of you will be or might be working in industrial security, right? There's a high need for it. Not everybody can do it because the lack of knowledge or experience or whatever it is. But if you look at if you work for a firm that implements a lot of IoT for companies, IT services firms, security firms, and they deal with clients in all aspects. Okay. So you have to understand certain protocols that is not your regular consumer protocol and standards. You're familiar with 802.11ac because that's what you use regularly in home and business, but you also have these, okay? Z-Wave is for home automation. This is for like your appliances, your refrigerator, garage door, that a lot of the things also use Bluetooth, right? That's through an app on your smartphone. But you also see Z-Wave being used for appliances, thermostat, stuff like that, right? Huge major flaw in some of these because of firmware issues. Just gotta make sure you patch them and making sure that the configuration is not default. And looking at the weakness in the protocol is the area of the security person. Okay. And then you've got ANT plus or ANT, right? This is for monitoring sensor data. So when you go to the supermarket and you see the refrigeration section, you know that there's a board to control the temperature, the moisture, all of that, right? Whether it's open refrigeration or those glass door refrigeration, right? And a lot of the times these type of devices use a sensor to also send out data. Lots of things use sensor. Farmland also use sensor. It's implemented in a lot of industrial system, right? So if you have some kind of sensor like for heat, moisture, let's say that I run a farm. I know it's legal for marijuana in California, right? You see a lot of this in desert hot spring. I used to drive to college in the desert, and when I pass by the town, you can smell it, right? So these warehouses, they have these plants, and these plants require proper light, proper watering, right? And control, and also physical control. So you see a lot of the sensor being implemented for those things for automation, because if you have a very large land space to grow, you would see, right? Bluetooth, you're familiar with. I think the new standards just came out recently. Near field communication, this is now with your tap and wireless pay, right? It is scary. Have you guys seen video of how these are breached? Or the Tesla keys? Right? Okay. Maybe that's for another class, but look up look up some information on how these things are. Near field communication, like airdrops, things like that. It's very convenient, but turn it off when you're not using it. Near field communication can come in different form, right? But when you're tapping your card at the payment, right? How easy it is for someone who stands by you with a reader. Like I said, the reader is illegal to build in some area, right? But there are technology now that you can buy for $200 that's able to do that with the proper adapter. So, and then infrared and RFID. So things like, you go to Target, those little tags, if you leave and you didn't pay, right? It sounds off. So they use RFID for theft tracking and all of those things. Or people don't go to the library to borrow books anymore. Unfortunately, a lot of the libraries are closed. But if you go to the library, you see those, when you walk through the door, those gate looking things that sends off if you try to pocket a book and leave, right? Those are RFIDs. Okay. All right. So the next step is just like configuring LAN or wireless LAN. For 23, before installing the wireless network, what should you consider when you do a site survey. So when you do a site survey, you basically use a signal reader and you walk the distance on how far is it your signal will reach its max, right? When you get the least signal, right? What is the length or the width or the circumference of the area that you're working with? So you need to consider your network scope, meaning how big is your network? How big is your wireless network? How many devices will be connecting? And with that, you can adopt the number of access point that you need. Remember, there's limitations to each access point. And the more you have device on the same network, right, the less signal that you will be. So it becomes bottleneck or congested. So the scale of your network is up important, and how many devices are connecting. The type of devices that you are going to use, so your endpoint devices, and also your network appliances, and their compatibility. Okay. And then I mentioned the expected capacity already. So in a school environment like this, right, we can make an assumption that, let's say the school has 7,000 students and maybe 1,000 employees. That's going to give you 8,000 users. And most of us now have mobile devices. So assuming that we would need to accommodate for that scale, and we would need to determine how many access points and how wide is going to be your wireless network, right? Do you have any questions for me before we end and take attendance? Okay,